In this video, we're going to talk about matrix addition, subtraction, and two types of multiplication. Let's just dive right in with an example. So I'm given two matrices, matrix A and matrix B, and I'm asked to find the sum of those two things. Now, when I look to find the sum and the difference, or when I add and subtract matrices, they have to be what we call equal, which means that they have the same number of rows, so these things going across, and the same number of columns. And the way that I would express that is, for example, matrix A and matrix B are both 2 by 4 matrices. So this kind of counting comes into play here and also with multiplication and other things that we can do with matrices. So it's very important to be aware of the number of rows and columns that you're working with. So the resulting matrix here is also going to be a 2 by 4, and it's not rocket science. All you really have to do is add the two numbers that are in the same position, and that will result in your new matrix. So if I were to write this out, I would take 2 and -3, right? And that's going to create -1, so that's going to be my first number in my matrix there. And then I'm going to take the next one. I'm going to do 4 plus 4. That'll be in the next spot. So I'm going to continue on. So once I work all of that basic arithmetic out, this matrix is our final sum. So now if I wanted to find the difference here, subtracting A minus B, obviously the order matters because we are subtracting, but you're going to do the same thing that we did with addition. So if we start this rather quickly and do it faster than what we did in the last slide, 2 minus -3, that's going to become 2 plus 3, that's 5. And then 4 minus 4, that's 0, etc. So why don't you pause it right now and complete the rest of the matrix, and then we'll check to see if we match up. All right, here's what I got. Did you get the same thing? Pretty sure you did. Congratulations. Let's move on. Another operation that you can perform on a matrix is something that we call a scalar multiple. So a scalar is any number, and I can actually attach that to a given matrix. So for example, I have matrix C, and what I'm asked to find is 1/3 of C. So that means that I'm going to multiply each number in my matrix by the scalar, hence scalar multiplication. So all that really looks like is I'm going to do 1/3 times 9, 1/3 times 0, 1/3 times -3, and 1/3 times 6. And this right here is my resulting scalar matrix. So matrix multiplication is not only limited to scalars. You can actually multiply matrices by other matrices. You can actually do it by a whole bunch of matrices. But the rule of thumb here is, number one, order is important. And you'll see that in just a moment. Number two is you have to be able to compare the rows and columns. Now, in addition and subtraction, you have to have the same number of rows, same number of columns. They have to be equal. In multiplication, that's not necessarily the case. But the two things that do have to match are the number of columns in the first one and the number of rows in the second one. So this is what I mean. In this example, I have a 2 by 3. And in my second matrix, I have a 3 by 2. These two numbers have to be the same. And the resulting matrix is actually what's left over. So my resulting matrix here is actually going to be a 2 by 2. So what I do is I set up a matrix and I leave some spaces for them just so that I don't mess up the configuration. You don't have to do it, but I suggest it. So the third thing, I think I'm on 3. If I'm not, whoops. So the third thing is, in order to find this number right here, you have to do a couple of steps. So I always like to think of it like going across and down. So what goes in this spot is going to be this times this plus this times this plus this times this. So let's actually write that out. So this number is going to be the result of 2 times 1, so this number and this number, plus 1 times 2 plus 3 times 3. So that's going to give me 13. And in order to get this number, I'm going to go across the top row and use the second column because this is in the top row, second column. All right, so let's do that out. So that's going to give me 7. Now, if I want to find this number, I'm going to use the second row, first column, because it's in the second row, first column. Let's work that out. So that's going to be -1, and our last value that's going to go right here is going to be in the second row, second column, because it's in the second row here, second column here. Let's work that out. That's going to work out to be -1. So to recap, matrix multiplication, make sure that you check these two numbers here, right? Number of columns and number of rows. And if you have those two things matching, the leftover numbers are going to create the dimensions of your new matrix. So this will work for any two-size matrices as long as these two things match. And that's going to do it for this video. Thanks for watching.